This is a recording that's covering the P1 section of the Calculus of a Single Variable 8th edition of the Larson book. I'm going to go through a couple of the couple things that are review, and then one thing that might be new to you guys. If it goes too fast, remember you can slow it down and rewind as many times as you guys need to. So we're just going to go ahead and get started. I'm also, during this recording, going to be using the TI and Inspire graphing calculator software. But you can use any graphing calculator to accomplish what we're going to accomplish. Alright, so the first thing we're going to talk about here is we're going to talk about parent graphs. And these are a few of them, they aren't all of them. The first one is a line, so and this should help you with the first few questions of the assignment. A line is the most basic line we can have is y equals x. But remember the general equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. So the slope here would be 1 and the y-intercept here would be 0. So you can see we've got a y-intercept of 0 and we went up 1 over 1 to go ahead and draw our picture of our line. A quadratic, or what we refer to sometimes as a parabola, the most basic equation is y equals x squared. In vertex form, quadratic is anything that's squared, but one form that we put it in to graph it easier is called vertex form. So in vertex form, remember h is the direction of the x, and remember we changed the sign inside the parentheses. The k is how much we would move it up and down, so it's the direction of the y. In this case, my h and my k are both 0. That gives me the x squared, and this is what a picture of that one looks like. A cubic is y equals x cubed, so anything with a cube kind of takes on this shape. The same hk pattern works for the cubic. This would also work if we dropped the cubic off of there, the squared off of there. If we put absolute value bars around it, it would work for absolute value as well. And remember, absolute value is just a v. A circle is x squared plus y squared equals 1. That's probably the most basic circle. I just picked a radius of 1. So that's what the picture of it looks like, obviously. There's kind of two generic equations. This is what it is if your center is at 0, 0, which our most basic one's center is 0, 0. But really the h and the k, putting that in there, that's how you translate your center. And your r is usually it's a square number there. It isn't always, but that's if you've got an x squared and a y squared and a square number, you're likely looking at some kind of a circle or some part of the circle. So let's talk about that for a minute here. So let's look at, let's say I want to get this onto an actual graph, okay? So I'm going to solve for y equals. So let's pretend our calculator won't just put that in. I know the Inspires will, but let's pretend it won't. Let's pretend it's one of the older calculators. I'm going to go ahead and I'm going to solve for y. So I'm going to move the x squared over by subtracting. And I'm going to undo that square. And to undo the square, of course, we take the square root of both sides. And we don't know if it was positive or negative, so we're going to do both. So y equals plus or minus the square root of 4 minus x squared. Alright, now, you may just have, to put it in our calculator, we could just put in the positive, or we could just put in the negative to get the whole circle. And that's how you have to do it on a lot of graphing calculators. So let's really quickly put that in our graphing calculator here and see what happens. See what we get pictures of. So I'm going to find my square root button, and I'm going to type in 4 minus x squared. And we know that because we talked about a circle here a minute ago. I should have done that first. We know that if we're talking about this circle, it's centered at 0, 0, and its radius, that's r squared, so the radius should be 2. So if I'm going to go ahead and hit enter on my, try it again. Control square root 4 minus x squared, enter. Alright, so you notice what we have is the picture of half of a circle because I only did the positive. If I also did the negative, and remember negative is under the 3 always, no matter which calculator you're on, 4 minus x squared, enter. Now I have the whole circle. Notice radius is length 2 all the way around the circle. So that's a way to get around it. A circle isn't technically a function, so we can't really put it into the calculator if we're putting it in function notation. Alright, so that's parent graphs. That should help you with the first couple of problems. Alright, so down to our first examples. I'm only going to do, unless it's something that we aren't that familiar with, I'm only going to do one of each type of example. You guys should be at the point where once I do one, even though the problems look very, very different, you should be okay trying the others. It says we got to sketch a graph equation by plotting a point. Well, if I'm going to plot a point, we're going to do a t-chart. Okay, so got our x's, got our y's. Pick a number that you like. Okay, so let's say I decided I liked 0. Here's the problem. When I put 0 in there, I get a negative under a radical sign. We know we can't have that. So I'm not going to even try to put in anything negative because I know that it's not going to help me out. So I'm going to pick another value. I could put in 1. So I know that 1 minus 1 is 0. Square root of 0 is 0. So I know the point 1, 0 is on the graph. Alright. If I was smart and I tried just values that came out to be squares, I'm going to try to force this to be a square number. So I'm going to say I'm going to put in a 2. Because 2 minus 1 is 1. Square root of 1 is 1. So I know the point 2, 1 is also on my graph. Alright, I could put in 3, but 3 is going to get me a square root of 2. And I can guess where that's at. What if I put in a 5? What's 5 minus 1? It's 4. So I put in a 5, square root of 4 is 2. That's reasonable. So out 5, up 2. Okay, I'm going to go one more. I really don't need to, but I'm going to go one more just to kind of prove the point. The next square number would be 9. So to get 9, I would do 10 minus 1, which is 9. Square root of 9 is 3. So out at 10, I'm up at 3. And you'll notice, and this is another graph, we didn't talk about it earlier, but this is like half of a parabola. Whoops. Not a very good picture. Half of a parabola, still missed. Or we will call that a square root graph. Okay? But any weird function I can give you here, you can always make a t-chart. Start picking numbers. If the number doesn't work, try another number. I usually tend to start around 0. Alright, we got to find intercepts. So intercepts is where it crosses the x-axis or the y-axis. So to find an x-intercept, and it's always the opposite. To find x-intercepts, you want to find where y is equal to 0. And notice, I gave you something that was weird, okay, because you're going to have weird ones in there. So I'm going to put 0 in for y, and I'm going to try to solve for x. So, that looks like I could factor it. So what's the greatest common factor? X. I'm going to take out an x, so I've got x squared minus 2. Good old zero product property rears its ugly head. So I've got, x equals 0. And x squared minus 2 equals 0. Okay, so I know that that's an intercept. But when we write intercepts, we don't just write x equals, because that's a line. So we'd have to write it as a point. So 0, 0. So 0, 0 is one of my x-intercepts. I'm going to move this to the other side. So I add it over. And I undo the square by square rooting, plus or minus. So I know that I have 2 more x-intercepts, actually. And remember, whatever your degree is, that's how many intercepts you should have. Somehow. It could bounce, it could repeat itself, but it could be multiplicity, but you should always have that many intercepts. So, again, I can't leave it like that. I could write that my other 2 intercepts are plus or minus square root of 2, comma 0. Now, that's just the x-intercepts. There's also y-intercepts. So to get y-intercepts, you have to put in 0 for x. So I'm going to use the same equation, put 0 in for my x's. Now this one, we already have the answer, but just to show you. We've got this, so 0 minus 0 basically is 0, so y equals 0. So again, has to be a point, 0, 0 is my y-intercept. We already knew that from over here. But it is possible that there could have been more than one, or it might not be the same. We might not get it just by finding our x. Alright, so this is the part that could possibly be new. We probably did cover it in Advanced Algebra 2 Math Analysis, but it was very, very quick and very, very long time ago. So this is a nice little chart that kind of tells us about the symmetry of a graph. So we know that something's symmetric to the y-axis. You have to sub in a negative x, and that means it has a mirror image across the y-axis, meaning you could fold over the y-axis. So if I folded on this line right here, I would get the same on both sides. Okay? To have x-axis symmetry, we test that algebraically by subbing in a negative y, and when we sub in, we should get the original equation back. The mirror images across the x-axis, so I need to fold across the x-axis. And then to have origin symmetry means that I'm going to rotate it 180 degrees, and this graph, when I rotate it, should fall on top of itself. And that means that when I sub in both negative x and negative y, I get the original equation back. So you sub in to get the original equation back. Alright, so we're going to test for all three different kinds of symmetry in this problem. So first thing it says I'm doing is the y-axis, so I'm going to sub in negative x. So y equals 2 negative x cubed minus negative x. And I'm trying to get back to that original equation. Well, I know an odd exponent, I keep the sign that I've got. So it would be negative 2x cubed, double negative is going to go positive. Did I get the original equation? Nope. So we know it's not y-axis symmetry. It can have more than one of the symmetries, so that's okay. Could have all three. So now I'm going to try x-axis symmetry, so I'm going to sub in negative y. So I'm putting in negative y equals 2x cubed minus x. Okay, I'm going to try to get back to my original, so I'm going to divide by the negative. So that gives me negative 2x cubed plus x. Did I get back to the original? Not on that one. Okay, so now I'm going to try subbing in both negative x and negative y. So negative y equals 2 times negative x cubed minus negative x. Okay, let's see what happens. I'm going to try to simplify that side first. So I know the cube's going to keep it a negative, so negative 2x cubed. Double negative is going to go positive. And now I'm going to divide everything by negative 1. So I've got 2x cubed minus x. And what do you know? We got the original equation back. So I do, on this particular one, have origin symmetry. All right, let's try it again. Okay, see if we can come up with some different kind of symmetry. Oh, we would probably want to write a sentence on this. I'm just looking at my notes. So we would want to say something like y equals 2x cubed minus x is symmetric with respect to the origin. Alright, let's try another one. So this time I'm going to sub in the negative x to check for y-axis symmetry. So y equals negative x squared over negative x squared plus 1. So when it's even like that, we know the negative is going to go away. So we get y equals x squared over x squared plus 1. Does it match the original? You bet. So we know it has y-axis symmetry. Alright, now I'm going to sub in the negative y. Check for the x-axis symmetry. So x squared over x squared plus 1. I'm going to divide that negative over. Alright, that one doesn't work, right? It doesn't match the original, so it does not have x-axis symmetry. And then the origin, I have to test the y and the x. So negative y equals negative x squared over negative x squared plus 1. Squared is in the wrong spot. We've got, when I square it, those negatives are going to go away. So I've got x squared over x squared plus 1. Then divide the negative to the other side. Okay, that one didn't work. So in this case, we know that y equals x squared over x squared plus 1 is symmetric with respect to the y-axis. let's try another example. So this one, not only do I need to test for symmetry, I need to identify intercepts, and they want me to sketch a graph. So by testing for symmetry and getting the intercepts, it should help me draw the graph of it. Okay, so let's start with the y-axis symmetry. So I'm going to plug in negative x minus y squared equals 1. So that gives me negative x minus y squared equals 1. Does that look exactly the same as that one? Nope. So this one's a no. Alright, I'm going to plug in a negative y now, check for x-axis symmetry. So x minus negative y squared equals 1. That would make it positive, but it's not a double negative. It's the square that's making the inside positive. That looks exactly the same. So it does have x-axis symmetry, so I know it's going to fold over this line right here, or that axis. I'm going to try the origin. So we've got negative x minus negative y squared equals 1. We know that that's going to go positive on the inside, and it does not look like the same thing, so it does not have origin symmetry. Alright, so now let's go ahead and try to calculate the x-intercept and the y-intercept. So remember, you go the opposite. So if I'm calculating x-intercept, I'm plugging in y equals 0. So x minus 0 squared equals 1. So we know that x would equal 1. So my x-intercept is 1, 0. It's not the same as a y-intercept this time like it was in our other example. So 1, 0 we know is the x-intercept. And we know that it's got to be on either side here. So it may or may not have a y-intercept. Let's try it. So I'm going to plug in, so to test for y-intercept, we plug in x equal to 0. So 0 minus y squared equals 1. So I've got negative y squared equals 1. I'm going to move that y negative over. Ooh, I can't have that negative under the radical sign, so there is no y-intercept. Okay, so now I want to try to graph this thing. So I need another point. I'm going to pick on another. Alright, so let's go ahead and finish graphing this. Sorry, I got interrupted. Let me erase that. There we go. Let's erase this. Okay, so now I got to pick another point. So just like we did earlier in the lesson, let's go ahead and try to pick another x value. So let's see. I've got I've got a square root kind of. So let's try something. Let's solve this. That's probably easier to do. So I'm going to move the x over. So I've got y squared equals 1 minus x. I'm going to undo the squared by doing the square root of both sides. And remember, I have to write a plus or a minus up front. So I have plus or minus 1 minus x. Okay. So now I want to pick numbers in here. A 0 wouldn't work because I get negative 1. A 1 might work, so 1 minus 1 is 0, which would be 0, which we already knew, right? Okay, a 2 might work. Let's try 2. 2 minus 1 is 1. Square root of 1 is 1. And remember, there's a plus or a minus out front. So I'd go up 1 and down 1. So there's actually, we get 2 points out of it, which really should be enough to draw it. And you'll notice, remember I was supposed to be symmetric about the x-axis. I am actually symmetric about that x-axis. Alright, let's keep going. So we're supposed to use the graphing calculator to graph this equation. And we're going to identify any intercepts and then also test for symmetry. So let's see if we can read the symmetry off the graph this time, since we're going to use a calculator for it. So first thing I want you to do is I want you to go ahead and get it into y equals. We're going to just pretend get it into function form. So I'm going to move the x over. I want to get it as the y by itself. So we've got x plus 4. And then I have to undo this by doing a square root of both sides and a plus or a minus. Square root of x plus 4, which means I'm really putting in, if you're using the inspire, you're going to put it into your f equals. Really doing this one, square root of x plus 4, and in f2 I'm going to put negative square root of x plus 4 to get both parts of the graph. Okay, so let's go ahead and try that. So I'm going to do a doc B here, clear my stuff off. Okay, and we're going to go ahead and do the square root of x plus 4. Make sure you hit enter. Alright, so there's the first part of the graph. And then I'm going to do menu, or no, sorry, not menu. Control square root. Oops, I messed something up. Let me get into my function. Double click or tab will get you in there. I'm going to do negative control square root of x plus 4, and that should give me the bottom half. Alright, so the question asked us, let's go back and look at that question again. Maybe. The question asked us, identify intercepts, test for symmetry. Okay, if I just look at this graph right here, what is the symmetry on it? Can we fold it across the y? Can we fold it across the x? Can we move it 180 degrees around the origin? Well, we can fold it across the x, so we're talking about an x-axis symmetry right now. And then we need to identify these intercepts right here. Now, these ones we could probably read off the graph. In fact, this one will have to because it won't pop up. But these ones here, let me show you how to calculate. Oh, well, let me do that, will it? No, it won't let me do it on this one. If it crossed properly, we could use the calculator to calculate the x-intercepts. So to do that, we would do menu, analyze graph, and you'd go to 0. And it's asking you which graph. I want to do, say, the blue graph, and it's going to want you to do the lower bound and the upper bound. Oh, the 0 came up. Good. So one of my zeros is at -4, 0. I can do the y-axis. I just have to trick it a little bit. I go back over here to my calculator. The x value here is 0. So actually, I could do it off the menu. So do menu. We could do trace and graph trace. And if you you could just type in where you wanted. So let's say it didn't say 0 there. Oops. Menu, trace, graph trace. I could type a 0 into this if I wanted to. And notice it came up 0, 2. If I clicked on this graph down here instead. Oops. Maybe not. Click on the graph you want first. Menu, trace, graph trace. Guess not. The other way to do it is I go to Scratchpad and I go to var, and let's say I want the F2 graph, so the second graph I had, and let's say I want to evaluate it at 0, which would be more my y-intercept is, I get -2. So we would want to write those things down. Alright, so we said that, oops, we know that from our graph we had x-axis symmetry, and that we had an x-intercept at -4, 0, and y-intercepts at 0, 2, and 0, -2. Or you could write plus or minus, that would work as well. Alright, we got to find the points of intersection. All this is a systems of equations problem. And remember, systems of equations, there's a bunch of different ways to solve it. We could use elimination, we could use substitution, or we could use Cramer's rule. I'm going to show you how to do this problem by both substitution and elimination. So we're going to do the same problem twice. So substitution, elimination. Okay, so let's do substitution first. Substitution means one of the coefficients is 1, and I got to get either x or y by itself first. So I'm going to choose to get the x by itself. So I'm going to subtract the y from both sides. So I've got x equals -y. I now take this and plug it into the second equation. So we've got 3x minus 2. I messed that up. Let's try that again. Alright, I need to plug in for x, not for y. Alright, so we've got 3, and for x I'm putting in -y, minus 2y equals 10. So you have to write it as a coordinate point, 2, -2. Alright, let's do the same problem by elimination. So for elimination, you have to have one of your coefficients match up but have opposite signs. So I'm going to choose to match up my x's, so that means I'm going to multiply this by -3. So I've got -3x minus 3y, and you also multiply this, so -3 times 0 is 0. And I'm just going to write down the other equation exactly the way it looks. Alright, my x's cancel. Negative 3y, negative 2y is negative 5y. And 0 plus 10 is 10. Divide by my negative 5, I get negative 2. I got to plug in. It doesn't matter which one I'm going to choose to plug into the top one. So x minus 2 equals 0 because I had to plug in for y. And I add that over and I get the exact same thing. So you get to pick whichever kind of equation or whichever kind of method you want. Now, it is possible, and I know we haven't done a lot of these, where you have to find the points of intersection of the graphs of the equations, and there's a squared in it now. So it doesn't work any differently. It just might throw a quadratic equation or a quadratic in here where we have to factor or use a quadratic formula or something. So I'm going to use substitution. So I'm going to go ahead and take this equation and I'm going to solve it for y. So I'm going to move the x over. So I've got negative y equals negative x plus 2. And divide by the negative 1. So I've got x minus 2. I now take this and I'm going to plug it in for the y in that equation. So I've got x squared minus, parentheses are very important here, x minus 2 for the y equals 4. I'm going to distribute that negative. Now you'll notice we've got a quadratic. I have to be equal to 0 to solve the quadratic, so I've got to move the 4 over, so I'm going to subtract. So x squared minus x minus 2 equals 0. I'm not going to show you how to factor. You're in calculus. Okay, so you factor it however it is you want to do it. Okay, so we've got x minus 2 times x plus 1 equals 0. And we zero product property, so x minus 2 equals 0 and x plus 1 equals 0. So x is going to equal 2 and x is going to equal negative 1. But wait, those are just x values. And notice it said points of intersection, not just point of intersection. So I actually have 2 points of intersection. So I'm going to go ahead and plug both of those into one of the equations. That equation, that second equation, is simpler. So I'm going to plug in the 2 for the x, so 2 minus y equals 2. Negative y equals 0, y equals 0. So I know one of my points of intersection is at 2, 0. I'm going to plug the negative 1 in for the x, so negative 1 minus y equals 2. I'm going to add the 1 over, and I'm going to divide by the negative, so I know that my other point is at negative 1, negative 3. Now, it is possible to use our calculator to help us out with this. So, some of them you're going to have to do what we call analytically, which is by hand. Some of them we can use the calculator to help us out with. Okay, so this one right here, what we're going to do to put it in the calculator is I want to put it in order for us to actually calculate the intersection points with the calculator, we need to have it as y equals. So let's get it as y equals first. Okay. All right. So I'm going to get y by itself. So I'm going to get y by itself on this one first. So I'm going to subtract the x squared over. So negative y equals negative x squared plus 3. I'm going to divide by the negative. So we kind of got lucky that the squared is on the right side, so we don't have to mess with it too much. X squared minus 3. Okay, and I'm going to end up putting this into F1 in my calculator. And then here, I am going to get the x over, so I've got negative y equals negative x plus 1. And we're going to divide by the negative again, so we get x minus 1. And this is actually going to go into F2 in my calculator. And we're going to use the calculator and let the do work analytically on this one because we just did that on the left. Alright, so in this example, we're going to go ahead and do the same thing we did in the last examples, except that we're going to put it into our graphing calculator. So in order for us to do that, and we actually need to, and actually being able to get them as equations that intersect, we're going to go ahead and solve each one of these for y equals, so they look like functions. So we're going to start by solving that one for y equals. I'm going to go ahead and subtract the x squared, and then I'm going to divide by the negative 1. So it's going to be x squared minus 3. So in that one, I'm going to put into my f of 1 function in my calculator. Now I'm going to solve this one for y equals, so I'm going to move my x over by subtracting, and then divide by negative 1. And then this is going to go into the F2 part of my calculator. So from here, we're going to go ahead and put this into our calculator. So I'm going to put in x squared minus 3, hit enter, and then I am also going to put in x minus 1, and hit enter. Now, I want to use the calculator to help me calculate those points of intersection. So to do that, I'm going to go to Menu, Analyze Graph, and see where it says Intersection. Grab that. And it says lower bound, so I take this line and I go to the left of it, and then I keep dragging till I see an intersection point, and I can pick it up and drag it over. I'm going to do that again because I see that there's 2 points of intersection. Analyze Graph, Menu, Analyze Graph, Intersection. To the left of it, to the right of it, and there's a point. Alright. Oops. Let me do this really quick. Alright, so those 2 points, those 2 points there would be our points of intersection. And we could try to do them by hand, and you could get them by hand just like we did in the last example. So that concludes this lesson, and go ahead and try the assignment.